Yeah. Yeah. Good evening, all. So myself, I'm Vijay. Like I hold 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, sir. Both are visible and audible.
Fine. Thank you. Hadoop and Spark. Yes. What is big data? So before I start, I am going to discuss the following topics. What is big data? Why Hadoop? Drawbacks with the current databases. So Hadoop advantages. Hadoop advantages. Hadoop and Spark job market, right? Market, yes. So first I'll be covering these topics. What is big data? Why Hadoop? Drawbacks with the current databases, Hadoop advantages, Hadoop and Spark job market, right? Big data. Okay. What is big data? Big data, right? The name itself saying like huge volumes of data. So currently, if you see the data is getting stored, the data storage units like KBs of data, MBs of data, GBs, gigabytes, terabytes, petabytes, exabytes, zettabytes, etabytes, sotabytes, so on, right? So from TB onwards, we say like huge data. So you should have seen KBs of data, MBs of data, or even GBs of data. But even if you should have seen TBs of data, but petabytes of data, is it getting generated? Petabytes of data, is it getting generated in the current real world? Petabytes or exabytes of data. 1 petabyte equal to 1024 GB. 1 petabyte, right? Yes. Equal to 1024 TBs. 1 petabyte equal to 1024 TBs. Yes. Examples of petabytes of data generation. So in the current real world, examples of petabytes of data generation, right? So if you take a bank like SBI or HDFC, right? Within the city, we see hundreds of branches. Within the entire state, we see thousands of branches for SBI. Within the entire country, like lakhs of branches for SBI. Again, each branch, millions of customers making multiple transactions per hour, per day, per week, per month, and year, right? Each and every transaction has to be stored. Huge data is getting generated, right? Some lakhs of branches within that millions of customers making multiple transactions, right? Huge data is getting generated. Yes. Okay. And one more example, right? Everyone are aware about the social media like Facebook. Facebook, right? millions and trillions of users for Facebook, not only within the country, entire world. So in a minute, what is the data generated by Facebook, right? Each and every post and video has to be stored. What should be the storage capacity to store all this? And what is the data generated by Facebook in a minute? Huge data, right? So not only Facebook, today we have got many applications which are going to generate data in petabytes. Examples, right? If I take only 1 minute transaction, just to take 1 minute transaction, in a minute, how many Facebook posts? Twitter tweets, Facebook, Twitter tweets, Google queries, right? What is the data generated by Google in a minute? And YouTube videos upload, right? YouTube videos upload. What should be the storage capacity, right? Facebook, Twitter, Google, right? Yes. And what is the Gmail messages? Gmail messages are what is the data generated by like bank transactions? Huge data, right? Bank transactions or telecom transactions or Flipkart or Amazon transactions, right? E-commerce, right? So everywhere we see like huge data is getting generated in petabytes of data, right? So currently we have got databases, right? Currently we have got databases for storing the data. So databases like Oracle, MySQL, SQL Server, DB2, all these they are used for OLTP, online transactional processing, OLTP, online transactional processing for day-to-day operations. But we have got some specialized databases. We have got some specialized databases. We have got some specialized databases. Like Teradata, Netija, Vertica, Teradata, Netija, or Vertica, right? Yes. Oracle, MySQL, SQL, DB2, OLTP, specialized database, Teradata, Netija, Vertica, OLAP. They are used for data warehouse purposes, DWH. Databases, Oracle, MySQL, DB2, they are used for OLTP. Teradata, Netija, Vertica, they are used for OLAP, analytical processing, data warehouse purposes. Fine. Okay. But to store, see, these databases can store up to GBs of data, and specialized databases like Teradata, Netija, Vertica, they can store TBs of data, terabytes of data, right? But to store petabytes of data are higher than that, right? So as a storage level problems and processing level problems, we have got a framework called Hadoop, which can store huge data. Petabytes of data are higher than that, like unlimited data storage is possible, right? Using Hadoop. Fine. So before I go with what are the Hadoop services, right? First, you need to understand how the data generations data generations, right? And what are the various sources of data, types of data. So if you take, this is the data which got generated from the last 50 years. So this is the data from 1973 to like 2023. So here, if we see 20%, 80%. So 1973 to 2013. From the last 10 years, if you compare with the previous 40 years, right? The previous 40 years, only 20% of the data is generated, but that 80% of the data, what we see in the current real world, right, has been generated from the last 10 to 15 years. What the reasons for huge data generation, especially from the last 10 years, usage of technology, usage of smartphones, and usage of internet. Technology, smartphones, and internet. If you see in 1990s or early 2000s, right, the data storage or secondary storage devices, like we got floppy disk, compact disk series, later you got like DVDs next, okay? The storage systems are keep on increasing, right, year by year. Now if you see in the earlier 2000s, when the mobile phone was introduced, right, the internal storage was just 128 MB. It was a huge storage, but now even 128 GB is a very less storage, right? So the sources from where this 80% of the data is getting generated, mainly three sources of data, right? Mainly three sources of data from where it is getting generated, like the social data, machine data, thirdly like transactional data. What is that? Social data, machine data, and transactional data. Data which got generated from social websites like Facebook, Twitter, all this data, like we call that social data. Machine data means data which got generated by reading or scanning the barcodes, RFID chips, such kind of data we call like machine data. For example, for the items you purchase, if you go to a shopping mall, right, for the items you purchase, you will get a very big bill is going to get generated, right? So reading the barcodes, reading the scanners, RFID chips, such kind of data we call like machine data. Transactional data from day-to-day operations like bank transactions, telecom transactions, right? Yes. And types of data, if you talk, mainly three types. It's going to occupy mainly three types, right? Structured data, semi-structured data, unstructured data. Structured data, semi-structured data, and unstructured data. Structured data, semi-structured, and unstructured. Example, structured data like database tables, Excel files. Semi-structured data like XML files, JSON files, which are not fully structured, which are not fully unstructured. Unstructured data like articles, images. Unstructured data like article, images, videos, short messages. All these are but today we see the data which got generated mostly is going to occupy unstructured format. Whatever the huge data is getting generated, right, mostly occupying unstructured format. So databases cannot handle unstructured data or semi-structured kind of data. They can only handle the structured data, which is in the form of rows and columns. So the biggest challenge is to handle this unstructured and semi-structured kind of data, where Hadoop can handle all varieties of Hadoop, and Spark can handle all varieties of data like structured, semi-structured, and unstructured. So day by day, as data is increasing enormously, we need to have some proper storage systems and processing systems, right? So as a solution to all the storage level problems and processing level problems, we have got a framework called Hadoop. Hadoop is meant for two things. Hadoop performs two things: storage and processing. Hadoop is meant for both storage and processing. It's meant for both storage and processing. Okay. So when Hadoop is able to perform both storage and processing, what is the necessity of the current storage and processing technologies, like storage technologies like Oracle databases, MySQL, DB2, SQL Server, right? And processing technologies like C or C++ or Java, .NET, all this, right? They're meant for processing. Do you think when Hadoop can perform both storage and processing, do you think this will be away from the market? No, you need to clearly understand these things like databases for day-to-day operations, for one transactions or two transactions, right? Right. But Hadoop is very bad for small data. Hadoop is good for huge data. For one transactions, two transactions, no need to go for Hadoop. For millions and trillions of transactions, we go for Hadoop. For batch applications, for batch processing. I'll be briefing you about much more on this batch applications or batch processing. But okay. So for huge data storage and for huge data processing, right? Go for Hadoop. And for storing the data, Hadoop, does it use any database internally for storing its data? No. For storing the data, does Hadoop use any database? No. Because databases has got some drawbacks. Despite of those drawbacks, still Hadoop doesn't go with any databases. It's going with a kind of file system called HDFS, Hadoop Distributed File System. It's going with a kind of file system called, and for processing, we are going with an execution model called as MapReduce or Spark. So yes, so for Hadoop, for storage, it is using a file system HDFS because databases has got some drawbacks, and for processing, we are going with MapReduce or Spark. Previously, MapReduce was used a lot. Now, currently, we are going with Spark processing, very high speed processing, right? Yes. Now, Hadoop is providing two services, right? Hadoop provides two services. Hadoop is meant mainly for two things. First one for storage, and second is for processing. Any technology performs either storage or processing. All the databases for storage, C, C++, Java for processing, but Hadoop performs both storage plus processing. For storage, it uses HDFS, Hadoop Distributed File System. For processing, we are going with the execution model called as MapReduce or Spark. Storage. Okay. Okay. Drawbacks. Why database like Oracle is not used for storing Hadoop's data? Drawbacks with the current databases. Drawbacks with the databases. First thing, most of the databases limited storage, like unlimited data storage is not possible. Huge data storage, like in GBs or in TBs. GBs or TBs. Second is like most of the databases, no parallel processing. No, in most of the databases, like no parallel processing, right? And if volume increases, speed decreases, right? If volume increases, see, if volume increases, right, speed decreases. If volume increases, speed decreases means, right? Select volume increasing, speed decreasing. For example, if I'm taking an SQL query, select total amount, sum of amount from sales one, right? Think it has got a 10 records. Select the total amount from sales one. It has assume that you got 10 records. Select the total amount from sales two. Think that if you got 1 lakh records, select the total amount from sales three table. Three tables. Select the total amount from sales one table, the total amount from sales two table, total amount from sales three table, right? So here it has got 1 crore records. Now try to say which query is going to execute faster. Total amount from sales two, total amount from sales three, 1 crore records. Sales one, sales two, and sales three.
Faster.
Which query is going to execute faster means the first query, right? Total amount of 10 records as compared with the second query 1 lakh or 1 crore, right? First query executes faster, next, second, and third, right? Query to query as the volume increasing. Query to query as the volume increasing, speed decreases. Query to query as the volume increases, speed decreases. Okay, next. Next, one more drawback, right? Is complexity increases. If complexity increases, what speed decreases. If complexity increases, speed decreases. Select sum of amount from sales one. Select average amount. Average amount from sales one. Select standard deviation, right? From sales one. Total amount from sales one. Average amount from sales one. Standard deviation of amount from sales one. See which query is going to execute faster among these three. Again, the first query, right? Because average amount is a two-step process. First, sum has to be calculated. Next, average has to be calculated as compared to the first one. Second one takes more time. And as compared to this first two, the standard deviation, lot of internal processing required. So query to query, as complexity increases, speed decreases, right? Yes. Okay, next. The major drawback of databases, like databases can handle only structured data. Databases can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data. They can handle only structured. They cannot handle unstructured or semi-structured data. For example, see that if you want, for example, if you want to take a reviews for a particular movie, right? A table, you got reviews table. Think that this is the table. User one, here user and review. User and review. Two columns. User one, user two, user three, user four, user 100. User one, user two, user three, user four, and user 100. First person saying the movie is good means one. Second person saying the movie is zero. First person of this one. So they are giving the feedback in the form of ones and zeros, right? They are giving the feedback. Okay. Can you write an SQL query to count the number of ones and zeros here? Can you write an SQL query to count the number of ones and zeros here? Count aggregation. Select a review wise. Excuse me. Review wise count I want. Review wise count from reviews. Select review wise count from reviews. Group by review. Select review wise count from reviews. Group by review. I want the output. Review 1 and 0, the count of 90 people saying the movie good, 10 people saying the movie is bad. Okay, 90 people saying the movie is good, 10 people saying the movie is bad. But generally, the reviews won't be taken in the form of ones and zeros, right? They'll give in their own text format. First person saying movie is good. Second person saying like movie is not good. In this way, the feedbacks are given, right? The reviews are given. Now, can you write an SQL query? Now, can you write an SQL query, right? Number of goods and to say the number of goods and number of not goods. So even if you use this keyword count, good, right? Keyword count. Okay, fine. Can you write an SQL query? I'm asking, right, to count the number of goods and not goods. Can you write an SQL query to count even by using a keyword count, right? If you just count it, right, even it gives wrong computation because even not good is has got good within it, right? Yes. So we cannot write an query, right? We cannot write a query to count the number of goods and non-goods, right? Fine. So yes, the major drawbacks, right? Yes. Databases can handle only structured, they cannot handle unstructured or semi-structured data. Next, advantages of Hadoop, right? Advantages of Hadoop. Hadoop advantages. See, first thing, unlimited data storage is possible. Unlimited data storage is possible in Hadoop. I'll be briefing you about with multiple examples in the tomorrow session. Unlimited data storage, very high speed processing, right? Huge data in quick time. Yes. And okay, unlimited data storage, very high speed processing. Yes. Can process all varieties, can handle all varieties of data, can handle all varieties of data. Open source, no licensing required. Open source, no licensing required. Commodity hardware, right? Commodity hardware, we doesn't require some very highly configured systems. No, any hardware is it's sufficient, right? We can just make a cluster. Commodity hardware. Okay. Can handle all varieties of data. Open source, no licensing required. Commodity hardware. Okay. So unlimited data storage, very high speed processing, can handle all varieties of data, open source, no licensing required, and commodity hardware, right? So these are the advantages of Hadoop, right? So Yahoo has conducted a test to check the speed of various databases, right? Yahoo has conducted a test to check the speed of various databases. It has taken a table, Yahoo has taken a table of 100 TB consisting of 1024 columns. The sorting task is sorting based on 16 columns, sorting based on 16 columns. Time taken by different databases, right? Yes. Oracle has taken nearly 3.5 days to process it. MySQL has taken nearly 6 days, right? Teradata, right? Specialized database used for data warehouse purpose. What is that? Teradata, right? Which is used for data warehouse purpose, right? It can handle TBs of data. It has just taken 4.5 hours. Next, another like Vertica. Just taken 3 hours, right? Another specialized database used for data warehouse purpose. Finally, Hadoop, right? It has just taken 3.2 minutes. 3.2 minutes. Latest version of Hadoop, just it has taken 2.1 minutes, right? So this what the speed of Hadoop as compared with the other things, right? So very high speed because of parallel processing. So in the tomorrow session, just I'll be briefing you more on this parallel processing, distributed storage, how exactly the storage and processing is happening, right? What is the cluster, how this cluster is maintained, master and slave architecture, right? Fine. Yes. So major advantages as compared with the databases, right? Databases cannot handle the major drawback with the databases. They cannot handle unstructured or semi-structured kind of data. But today, huge data is getting generated. That most of the data is in unstructured format or semi-structured format, right? Yes. Mm. So Hadoop can handle all varieties. Hadoop can handle all varieties of data, right? It's open source, no licensing required. It's a cross-cutting, right? Yes. And commodity hardware. Commodity hardware, right? So that is what related to Hadoop I discussed, right? I also give some introduction to this Spark, PySpark, right? I just give some commodity hardware. Commodity hardware means so not like highly configured hardware configuration not required. Just whatever configurations, any hard, it doesn't mean that all the systems should have the same hardware configuration. No. Any configurations, that too, whether it is high configured or low configured, any configuration, fine, it allows within the cluster. So what is Apache Spark? What is Apache Spark? Why PySpark? So some need for PySpark. Real life usage of PySpark. PySpark job market, right? Okay. Spark. If we can say Apache Spark is a open source, distributed cluster computing framework introduced by Apache Software Foundation. What is that? Apache Spark. Open source, distributed cluster computing parallel processing framework, which was introduced by Apache Software Foundation. See, it's a Apache, this PySpark, this engine for big data analysis, right? For processing and computations. See, if you say why PySpark is required, right? Yes. It is a Python API to use a Spark. PySpark is a Python API to use Spark. Yes, it is a PySpark is the lightning fast technology. It is designed for fast computations. PySpark is one of the demanding tool, right, among data engineers to work with bigger data sets or bigger data solutions, right? So it is PySpark used for running distributed SQL, running distributed, creating data pipelines, ingesting data into a database, ingesting data into a database, running machine learning algorithms, graphs or data streams, graphs or data strips, and many more, right? So need for PySpark. So what is the need for PySpark? So if you see large amount of data or huge amount of data is getting generated, right? Both through offline and through online. This data contains hidden patterns, unknown corrections, market trends, customer preferences, user preferences, right? And other useful information. It is necessary to extract the valuable information from this raw data, right? So we require some more efficient tools to perform different types of operations on this big data. We already we have got various tools to perform this task, right? Operations on this huge data set, but these tools are not so appealing. So we need some scalable and flexible tools to crack the big data and gain benefit from it. So PySpark is such a kind. So combining Python and Spark will be the very efficient way for the world of big data. So that's why Apache Spark community came up with a tool called PySpark, Python API for using Spark. Okay, fine. And what is the real life usage, right? Real life usage of PySpark. Real life usage of PySpark. Mostly used in the commercial sector. Usage of PySpark used in the commercial Apache Spark real-time processing, banks and other financial fields, right? They use PySpark to retrieve the customer's social media profile and analysis to gain useful insights from that, and we can help in taking the right decisions, right? And also in credit risk assessment, Spark plays PySpark plays a vital role in fraud detections also, right? Real-time processing. And it is also used in healthcare. Healthcare, right? Used to analyze, it is used to analyze the patient's records. Used to analyze the patient's records along with the previous medical reports and to identify which patient is mostly going to face this issue, right? Even after being discharged from the clinic, right? And even in the entertainment industry, right, it is used. PySpark, entertainment industry. So it's in online entertainment industry is one of the largest sector which is growing towards online streaming. The popular online platform Netflix uses Apache Spark, right, for real-time processing and for personalized online movies or web series. So it processes 450 billion events per day that are streamed over server-side applications, right? And even for trade and e-commerce, for trade and e-commerce. Trade and e-commerce. Trade and e-commerce, right? Yes. Um, like Flipkart, Amazon, all these they use Apache Spark for advertising and other websites also these websites they provides enhanced customer experience, optimizes overall performance, right? Yes. For kind of recommendations and for kind of advertisings, right? This Spark, PySpark is preferred. Even for the tourism industry, right? Tourism industry. So which Apache Spark, PySpark to provide advices to millions of travelers by comparing the hundreds of tourism websites, right? Yes. In this way, yes. So today, like ETL kinds of projects, previously Informatica kinds of projects or ETL kinds of projects, where, right? Those projects are getting migrated towards this Hadoop and Spark environment, right? So if we can see this Hadoop and Spark has got, especially like Spark has got, PySpark has got a great boom in today's market. You can just check the packages of it, especially PySpark packages, right, as compared with other technologies, right? 1.5 times more than the other technologies. Same way, they want to have the command on this technology, right? So that's why we are going with it's a 10 weekends batch. It's not like 6 or 8 weekends, like we are taking like 10 weekends and we are spending more time with many working examples. You can just go through the course content, right? Yes. What is big data? Why, what is Hadoop? Need for Hadoop sources, challenges, databases in Hadoop. HDFS, Hadoop distributed file system, features, name node, data node, HDFS architecture. I'll just give me 5 minutes. I'll just give you time for your queries. Metadata management, storage and processing, map reduce processing, job tracker, task trackers. Yes, and scoop SQL. The first two characters SQ taken from SQL. Last three characters they're taken from this. SQL plus Hadoop, right? Yes. Scoop, combination of SQL and Hadoop. Introduction to Scoop, Scoop import, Scoop export, importing data from databases to HDFS, importing data from importing data from RDBMS to HBase, exporting from HBase to database, exporting from HBase to exporting from Hive to databases. So for importing and exporting operations, For importing or exporting operations, right? We go for this. And yarn, yet another resource negotiator. So in the previous Hadoop versions, there were some little drawbacks. Everything got rectified from this Hadoop 2 version onwards. So we have got some architectural changes, some advanced features. NoSQL database. As part of the course, I'll be discussing from NoSQL database. HBase is that NoSQL database. Random access. Hive. Hive, right? Hive architecture. Hive is one of the important component of Hadoop, which is a kind of data warehouse kind of environment where we can create tables, make the data structured and create tables, internal, external tables, working with unstructured XML data, JSON data, URL, weblog data, joins, unions, file inserts, UDF, UDF, UDTFs, right? Partition, non-partition, static partitioning, dynamic partitioning, multi-column partitioning, bucketing, indexing, right? With many. Next, coming to this PySpark, right? Right, Apache Spark, PySpark, PySpark's context, RTD, parallelizing, repartition, broadcast variables, accumulators, like RTD transformations, persistence, persistence options, PySpark core computing, groupings and aggregations, various actions, inbuilt actions and transformations, their inbuilt functionalities, zip union and PySpark SQL data frame, right? Right, data frames. Yes. So what is struct type, struct field, select, collect with column rename, drop, filter, order by group by union for each sample, fill nulls, pivot, partition by array type, date and timestamps, JSON functions, window functions, aggregate functions, various built-in functions, right? Can get, substring, translate, overlay, to date format, date difference, month difference, explode, array contains, map keys, map values, struct, sum, average, rank. So all the built-in functions and external sources, right? Working with SQL statements, Hive integration, working with CSV, JSON, narrow and wide transformations, new rows, dropping new rows, deployment modes, local mode, cluster mode, PySpark application, stages and tasks, driver and executor, building Spark applications, deploying Spark applications, performance tuning, Spark streaming concepts, in integration with Kafka and Spark machine learning, right? This is what in brief, in depth, it will be discussed. So it's 10 weekends batch, right? If you've got any queries now, go with your queries, right? So before, right, 1 second. So every session is video recorded. You will be getting the recorded video of that session, clear notes, that is soft copy of the notes, many working examples, and a WhatsApp group will be created for technical discussions, right? That is the offerings from outside. Tomorrow also you can attend the session same time at 5 o'clock with the same link to see more on this, right? It's like continuation to today's demo, not repeating, it's not a kind of duplication, right? Or replication of today's class. If you got any queries, you can go with the queries, right? Yes.
Sir,
Yes.
so like for searching for the what kind of job roles and we will get after completing this course, like in the we will go for uh,
So this is
like
most,
being a new person to this background.
so this is totally a development course, right? It's a PySpark or is Hadoop. You go like Hadoop or Spark developer, right? A data engineer.
Okay, so we will be called as a big data engineer kind of thing,
Yes.
like person.
Data
So we will
engineer.
search like we will make our profile like resumes in the form of like a Spark developer or like
So
Hadoop developer.
Hadoop and Spark developer we say, and data engineer we say like this. So where you are going to take the data, pull the data from different sources, extract and transform as per the business logic, and loading it right into this HDFS, and also like exporting to different other data sources. So about all those things, right? Roles, responsibilities, everything I'll be discussing at the end of that, right? Course.
Yeah, like
What are the roles?
suppose.
What are the roles, responsibilities, right? Everything, and some resumes, everything I'll be providing you. Then, fine.
Okay. Okay. And sir, what will be the duration of each classes on the weekends, like Saturday, Sunday, like
2 hours on Saturday, 2 hours on Sunday, totally 4 hours.
okay, okay,
If
okay,
sometimes in the
each.
practicals, I may extend by some half an hour, right? Yes.
Okay.
So each day 2 hour or in a weekend is 2 hour.
No, no. Saturday you'll have 2 hours class. Sunday you'll have 2 hours class. Totally.
Am I audible?
Yes, yes. So Saturday you'll have 2 hours
Hello?
class. Is my voice clear to all? Hello? Is my voice clear
Yes,
to
sir.
all?
Yes, sir. Yes, sir. Yes, sir.
Saturday 2 hours you'll have class, 2 to 2.5 hours. Sunday also you'll have 2 to 2.5 hours class. Totally 4 to 5 hours class per week. Yes.
What is the prerequisite for this course?
Oh, pardon?
Prerequisite for this course.
So prerequisites, right? Yes. So you need to have the basic SQL knowledge. Basic Linux knowledge is required, but still if it doesn't have, I'm going to provide the knowledge on
Hello?
Linux. Is my voice clear or not?
Yes, 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 sir.
So yes. So
Basic SQL, Linux and Python.
so Python also basic Python knowledge is required. Still, if you doesn't have knowledge on Python, right? Still, I'll be giving the before I go with PySpark, just I'll be
Hello?
providing you the syntaxes of all the Python, right? Python syntaxes. But still, if you are able to, if you doesn't have, if you are able to update still before we start with PySpark, right? Like we have got like 1 month or one month time we have got, right? You can even update with that Python. Even I take some Python batches, right? Fine.
And sir, is there any need of the cloud for this course?
Yes, at the end of the session, at the end of this, right, I'll also show how to do this within the cloud environment also, right? I'll also give the knowledge on how to do go with the cloud environment, right, on this.
GCP or AWS?
So Azure, right? Azure
Azure.
Databricks, ADB, we say Azure Databricks.
Okay. Means what is the whatever necessary cloud required for this course? We will teach that one
So
at the
here,
end.
see here, totally not that. I'll show you right on this on this online, that is offline premises, right? We are going to generate a cluster, right? Cluster of systems, but and the cloud environment also, and said I'll be showing you at the last.
And sir, can we put experience after complete this course? Can we
Yes,
add
yes.
experience?
A typical 4+ years experienced person, how much knowledge is going to gain? That much you will be getting, right? In brief,
Means
in
so
depth. Yes.
if 4 years experience, we maximum
Yes.
4 years.
3+4+ experience you will be getting.
Okay.
So how good command you have got, based on that you can keep that knowledge, right? That is experience you can keep. So that's
Sir,
why
how
that's why it's a 10 weekends. It's not 10 weekends batch, takes 3 months, right? Yes.
okay. And sir, means total 50 hours will required. You are
Yes,
saying
yes,
like that.
yes, yes. So tomorrow also you can attend the session, sir. Then yes, one project flow I'll be discussing at the last, right?
Means,
Yes.
sir, companies are asking cloud if we are we have big data engineer roles. They are
Mm.
asking means cloud. That is why I had asked for that
Yes, yes.
that
Then
question, sir.
also, right, how to perform these things in the cloud environment also I'll be discussing at the last.
And sir, do we need hands-on practice on the Python for this course, or only basic required?
Python basics required. For Python core
Python.
programming is required.
Okay, sir. Okay. Thank you, sir.
Okay, fine. Fine. So if I'm done with your queries, if there are no other queries, I'll sign off for now. Meet you tomorrow, right? At 5 o'clock. Same time using the same link, right? Thank you all for your time. Thank you. Meet you tomorrow.